Hi, thanks for joining me. Today we're going to be doing an integral video. We want to compute the integral from 0 to 2 pi of cosine of x times cosine of 2x times cosine of 3x dx. Okay, so if you want to have a go at evaluating this integral, pause the video now and give it a go for yourself, and I'm going to get stuck straight into a solution. Okay, so there are in fact at least two different ways you can solve this integral, one of which is a very brute force method where you expand this guy out using some double angle formulae, and then you kind of just compute an antiderivative which is very long and very ugly, and then plug in 2 pi and 0 and you get the solution. However, that will take a long time, a lot of writing, there's nothing too interesting to say about that, and also there are a lot of steps, so it's easy to make a mistake. What we're going to actually do is exploit some symmetry and use some really nice tricks to be able to evaluate this integral. The first thing I'm going to do is actually just skip a few steps, and I'm going to write out how we can express this integral in another way, and if you want to, I'll leave the intermediate steps as a little exercise for you, but this integral here is in fact the same as 4 times the integral from 0 to pi over 2 of cosine of x, cosine of 2x, cosine of 3x dx. Okay, and the reason this is true is you can go from this line to perhaps one of the intermediate lines by splitting this integral from 0 to pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi, so you have 4 different integrals, and then you show that each of those integrals are in fact the same, using perhaps a translation use substitution, but I didn't want to write that out because I'm a little bit lazy, so we're just going to go from this line to this line, and you can either trust me or convince yourselves by doing the intermediate steps yourself. Anyway, I is equal to 4 times now this integral here, so it's the same integrand except now it's just 0 to pi over 2. Now, what is this integral? Well, we're actually just going to give it a name. We're going to call this integral here j for now. And what we're going to do is try and work out an expression for j, or sort of a value for j, from which then we'll be able to work out a value for I. Okay, so what we're going to do on j is actually a u substitution. So if we're going to have x equals pi over 2 minus u, which is equivalent to saying u equals pi over 2 minus x. Okay, so then we're going to get j equals the integral now. Well, when x is 0, u is going to be pi over 2 minus 0, so pi over 2. And when x is pi over 2, u is going to be pi over 2 minus pi over 2, which is 0. Now, cosine of x is just cosine of pi over 2 minus u, which using your double angle formulae, you'll be able to find out that that is just sine of u. Now, cosine of 2x is cosine now of pi minus 2u. And then using your double angle formula again, that will be minus cosine of 2u. Okay, and then cosine of 3x now is cosine of 3 pi over 2 minus 3u, and then using your double angle formulae, you'll be able to see that that is just minus sine of 3u. Okay, and now dx is just minus du, but we can actually use the minus sign from the minus du to flip the limits of integration, so we just get du here, and we can flip the limits of integration like so. So this now 0 to pi over 2. Okay, and of course, we can cancel out these minus signs from one another, like so. And so now we've got the integral from 0 to pi over 2 of sine u cosine 2u times sine of 3u du. And of course here, u is just some dummy variable, so we can actually replace it for an x now. Okay, so kind of ignoring this and just replacing the u's for x, because remember, it is just a dummy variable. Okay, so now we've got two different expressions for j. One being this guy here, the integral from 0 to pi over 2 of sine x cosine 2x sine 3x dx, and this one here being the integral from 0 to pi over 2 of cosine x cosine 2x cosine 3x dx. What we're going to do next is add up these two values for j and use some nice integral tricks to then evaluate j, from which then we can evaluate I. Anyway, let me clean up the whiteboard and we'll continue. Okay, so let's just recap what we've done so far. We have this initial integral I, which we're trying to evaluate, and we've shown that it's equal to 4j, where originally we defined j as this integral here, but then we just showed that j is also this integral here. Now what we're going to do is add up these two lines here. So the left hand side is just j plus j, which is 2j, and the right hand side now is just two integrals summed together, but notice both of the integrals are from 0 to pi over 2, so I can actually bring them all under one integral sign, like so. And now we see that we're doing this function here, so cos x cos 2x cos 3x plus sin x cos 2x sin 3x, and then what we want to do is put that all in one integral, but let's take out a common factor of cos 2x first. Okay, and then in brackets we've got cos x cos 3x plus sine x sine 3x. dx, like so. Okay, so now we've got this integral here. Hopefully you can see that there's a nice way we can kind of collapse the thing in square brackets into one term, using the fact that cos A minus B, so in brackets cos A minus B is equal to cos A cos B plus sine A sine B. So this is in fact cos 3x minus x. So this guy here is just cosine of 3x minus x. Okay, because if we were to start from this side, perhaps it might be a bit easier. So if we start from cos 3x minus x, using our double angle formula, that's cos 3x times cos x plus sine 3x times sine x. So it's exactly this thing here. And obviously 3x minus x is just x. So this is just cos 2x. So in fact, 2j is just the integral from 0 to pi over 2 of cos 2x times cos 2x dx, which of course we can just write then as cos squared 2x dx. So all of a sudden our weird looking integral in terms of cos x, cos 2x, cos 3x has collapsed down into the integral from 0 to pi over 2 of cos squared 2x dx. And now we can just go ahead and use our double angle formula to evaluate this. This is just the integral from 0 to pi over 2 of a half plus a half cos 4x dx. Okay, and now working out the antiderivative of this. So by the way, just going from here to here, I've just used double angle formulae for cosine, okay, where my theta is just 2x. Okay, and then evaluating this out, we get that this is a half x plus an eighth sine 4x. Okay, because obviously the derivative of sine 4x is just 4 cosine 4x. So the 4 here will multiply by the 1 over it to give me the half at the front. Okay, and this half x obviously differentiates to give me a half. And then we're doing that from pi over 2 to 0. When I plug in pi over 2, I get a half pi x, so a half times pi over 2, which is just pi over 4. And then this sine term will actually evaluate out to 0 in both cases. So when x is pi over 2 and when x is 0, we're going to get 0. So in fact, and obviously when we plug in x is 0 into half x, we're going to get 0. So all in all, this is just pi over 4. So we get that 2j is equal to pi over 4. So then that means that 4j must be equal to pi over 2. So if 4j equals pi over 2 and I equals 4j, we then get that I must be equal to pi over 2, like so, and we're done. So our crazy looking integral that we started off with, cos x, cos 2x, cos 3x, using some symmetry to write j, or write it in terms of j, and then using a little u substitution to get j in other terms, adding them together, using some other double angle formulae tricks and stuff like that, meant we can evaluate 4j, or we could evaluate j, which obviously meant we could evaluate 4j as this nice pi over 2 number, and we get that this integral here is just pi over 2. Anyway, thanks for watching. I'll catch you in the next one. Have a great day.